All right, let's dive into one of the most fascinating moves happening in AI right now. We're talking about a multi-billion-dollar bet that, honestly, goes against everything we thought we knew about the hardware that powers this whole revolution.
So here's the deal. In a world where Nvidia is the undisputed king of AI chips, they dominate the market, one of the top AI companies, Anthropic, decides to bet billions on something different, Google's TPU chips. It's a move that made a lot of people go, wait, what? Why would they do that? What exactly did Anthropic see that maybe the rest of us missed? Well, that's what we're going to unpack right now.
Okay, so to really get why they made this call, we've got to bust a major myth about performance. See, it turns out that the biggest, flashiest number on the box isn't always the one that actually counts. You've probably heard the term FLOPs, right? It stands for floating point operations per second. It's the standard way we measure a chip's raw power. Think of it like a car's top speed. A supercar might boast it can hit 250 miles per hour, but let's be real, you're not doing that on your way to the grocery store. It's just potential.
And that right there brings us to the absolute core of this whole story. There is a massive difference between theoretical flops, that perfect world lab conditions number, and what we call effective flops. That's the actual speed you get in the real world with all its messiness and bottlenecks when you're training a giant AI model. At the end of the day, the number on the spec sheet doesn't matter. What matters is what it can actually do.
So you're probably asking, why is there such a huge gap? Well, it's kind of simple. Chip makers for marketing push their hardware to the absolute edge to get those headline-grabbing numbers. But in the real world, you can't run a chip at that speed for long because of power limits and heat. Plus, some of these performance tests, they use, let's say, unrealistic methods, like they'll multiply huge tables of numbers that are all just zeros, which is way easier for a chip. The bottom line is this. When you're doing actual heavy-duty AI training, you're lucky to get about 30% of that peak performance out of a GPU.
And this is where the light bulb goes on and Google's entire strategy starts to click into place. See, they're not playing the same game. They aren't just trying to build the fastest chip, they're building the most effective system.
There's this quote that just nails it. Systems matter more than microarchitecture. It's so true. Having a beast of an engine is great, but it's totally useless if you don't have the transmission and the chassis to actually get that power to the road. For AI, the system is all the stuff that connects thousands of these chips together and makes them work as one. And you have to understand, Google has been playing the long game on this for years. Since way back in 2017 with their TPU v2, they've been obsessing over how to link thousands of their chips together perfectly. This system-level engineering is pretty much the only thing out there that can truly compete with Nvidia's famous NVLink. And the proof is in the pudding, right? Google's incredible Gemini Pro model was trained completely on TPUs.
Just look at this. This shows you the real-world impact. In a super complex simulation of a business, a task that requires thinking over a long time, Gemini Pro, trained on these TPUs, just blew the competition out of the water. We're not talking about a quick drag race here. This is about sustained, effective performance on really hard problems. And that is exactly what Google's system is built for.
Okay, so we've established that the system gives them better effective performance. But the story gets even better when we follow the money. Because in the world of AI, the sticker price of a chip is just the beginning. The real cost is the total cost of actually getting the work done. To really get this, we have to talk about a key metric called MFU. It stands for Model FLOP Utilization. All it means is what percentage of that theoretical power we talked about can you actually use for your AI model. It's simple. A higher MFU means you're being more efficient, you're wasting less, and that makes everything cheaper. And this is the secret sauce for Anthropic. You've got to remember, these guys have some of the best engineers on the planet. Many of them are ex-Googlers who know the TPU system like the back of their hand. So they can tune their AI models to perfectly match the hardware, getting way more performance out of it. We're talking about achieving a much higher MFU than your average company could ever hope to get from a standard GPU.
All right, let's look at the actual numbers, first from Google's point of view. What this chart shows is the cost for the same amount of effective computing power. So check out the orange bars on the left. That's Nvidia. At a typical 30% efficiency, the cost is, say, somewhere around $2. Now look at the blue bars for Google's TPUs. Because their internal costs are just lower, they only need to hit about 15% efficiency to be just as cheap. Anything above that is basically pure profit or savings for them.
Okay, but what about for Anthropic? They're renting this stuff, so Google is taking a cut. This next chart shows their costs. And wow, even with Google's profit margin baked in, the math is amazing.
For Anthropic to break even with the cost of using Nvidia, they only need to be 19% efficient. That's an incredible safety net. It means they could be way less efficient than someone using Nvidia and still save money.
But what happens when Anthropic's expert team does what they do best and pushes that efficiency up to, say, 40%, which is totally achievable for them? The result is just staggering. A 52% lower total cost. 52%. That is an absolutely game-changing amount of money.
So we've got a technical edge that creates a huge financial edge. But what does that actually mean? So what? How does that change things out there in the real world, in the marketplace?
Well, it means you can take those massive savings and pass them right on to your customers, and that's exactly what Anthropic did. They were able to cut the price of their top-tier model Opus by about 2/3. Just like that, their best-in-class AI became way, way cheaper, and that completely shook up the market. When you put it all together, what you have is just a brilliant win-win situation. It's a perfect partnership. Anthropic gets access to incredible performance for a fraction of the cost, and Google gets the ultimate stamp of approval for its entire AI system.
And look, the numbers prove this was a home run for Google. This table is a little busy, but just focus on the profit margin column. The deal with Anthropic is estimated to have a 44% margin for Google. That's huge. It proves that their TPU system isn't just some cool tech experiment. It's a massively profitable business that sets them apart from everyone else who's just reselling the same Nvidia chips.
So in the end, Anthropic's big bet wasn't really on a chip. It was a bet on a whole philosophy. The idea that a tightly integrated, fully optimized system is more powerful than just having the single fastest part. And so far, it looks like that bet is paying off in a huge way. It really leaves us with a big question for the future of this industry. As AI gets more and more complex, will the best system always end up beating the fastest chip?